Imagine looking at Earth from space and seeing a frozen sphere, a planet completely covered in ice, from pole to equator. This isn't the plot of a sci-fi movie, it's a real chapter in Earth's history called Snowball Earth. But how did our world end up frozen solid, and more importantly, how did it escape this icy prison? Let's rewind about 700 million years, long before dinosaurs or even plants. Life on Earth was still mostly microscopic, thriving in oceans under a greenhouse atmosphere rich in carbon dioxide. But something dramatic began to change. Temperatures started to drop and glaciers formed near the poles. These glaciers didn't stop, they kept advancing, creeping closer to the equator. So, what triggered this icy catastrophe? Scientists believe it was a combination of factors, a perfect storm of natural events. First, volcanic eruptions spewed ash and gases into the atmosphere, blocking sunlight and cooling the planet. At the same time, chemical weathering from mountains scrubbed CO2 out of the atmosphere, weakening Earth's greenhouse effect. As the planet cooled, ice reflected sunlight back into space instead of absorbing it, a phenomenon called the albedo effect. The more ice there was, the colder it got, creating a feedback loop that eventually froze the entire planet. Picture this. Oceans turned into massive ice sheets hundreds of meters thick. Glaciers covered continents and even tropical regions were locked in ice. Earth became a shiny white marble spinning in space. Temperatures likely dropped to -50 degrees Celsius in some areas, and life clung to survival in small isolated pockets of liquid water beneath the ice. Here's the big mystery. How did life manage to survive such extreme conditions? Scientists think tiny microbes found refuge in deep-sea hydrothermal vents, where warm, mineral-rich water provided a safe haven. Other organisms might have lived in pockets of liquid water under the ice or around volcanic hotspots. It's a testament to life's incredible resilience. But how did Earth escape this deep freeze? The answer lies beneath the ice, in volcanoes. While the planet was frozen, volcanic activity continued, pumping carbon dioxide into the atmosphere. Since there were no plants or weathering to absorb this carbon dioxide, it built up over millions of years, creating a massive greenhouse effect. Eventually, the planet began to warm, melting the ice and flooding the atmosphere with water vapor, which also trapped heat. This dramatic thaw marked the end of Snowball Earth, leading to one of the most important periods in Earth's history, the Cambrian explosion, when complex life forms rapidly diversified. Snowball Earth didn't just shape the planet's climate, it also had a profound impact on life. The harsh conditions may have driven evolution, pushing life to adapt and find new ways to survive. This set the stage for the rise of multicellular organisms and eventually the complex ecosystems we see today. Here's a question. Could Earth freeze over again? Technically, yes. If conditions were right, such as a massive drop in greenhouse gases, another Snowball Earth could theoretically occur. However, the presence of life, particularly plants and humans, makes it much less likely. Snowball Earth is a story of survival and transformation. It shows us how fragile yet resilient our planet can be. From a frozen wasteland to a thriving blue-green world, Earth's journey reminds us of the delicate balance that keeps life going. Want to uncover more epic events from Earth's history? Hit that like button, subscribe to BrainSpark, and join us on this incredible journey through time.